arranged. Simply, I got this order according to that. So I will verify once. N plus L values, right? Here, N value is 1 and L value is 0. So I got here 1 plus 0 is 1. Here for this one, 2 plus 0. So I got N value is 2. Then 2 plus 1. Here it is giving you 3. Then here 3s. 3 plus 0. Here it is giving you 3. So we got the same values here. We assigned same values for this both. Right? So in this case, what we are doing, if you got same energy in any orbitals, right? So what least N value? So least N value is for 2p, not 3s. So that's why 2p is filled first, next 3s. Right? So like that here, in case of 3p, what you are able to calculate here, 3 plus 0, 3. Oh, sorry, 3 plus 1, it is 4. 3 plus 1, it is 4. Okay, 4s. 4 plus 0, 4. So here also I got same. So what should I do? Least N value. So 3p is first. Next, 4s. Next, 4s. Is it clear? Audio is not clear? My audio is clear? Are you able to hear my voice? Yes, it is clear. Someone raised a problem that is here by Tejaswini. Just rejoin yourself. Rejoin yourself into the meeting. Just exit, and rejoin. Okay, so here I'm able to calculate like this. So everything, every orbital with N plus L value, we are arranged in the increasing order. So by using this, you are filling the electrons. By using this, you are filling the electrons. So I think it is clear about above principle. Do you got clarity here in this above principle? Any confusion is there? Right? So now we are using this above principle to fill the electrons. So to fill these electrons into the orbitals, I'm using here hydrogen, only one electron. So there is no problem. So I'm able to fill the electron into the orbital 1s. Just a second. Voice is clear? Just I got notification here on the screen. Everyone, is it audible? Yes. Okay. Right. Now here I'm going for the second atom. That is what helium. For helium, atomic number is 2. So filling that electron 2 into this. So with the anti-parallel spin, as I suggested by Pauli's exclusion principle. So 1s2, there is no problem. Then I'm going for the next one. Lithium. Atomic number is 3. So 1s2, clear. First 2 electrons filled into 1s. Then next 2 electrons filled into the 2s. 2s1. Lithium. 1s2, 2s1. Then next beryllium. Beryllium is 4. So 1s2, 2s2. Okay, no problem. According to that, Pauli's exclusion principle and above principle, I am filling that electrons. Then I am going for boron, 5 electrons. So 1s2, 2s2 filled. Then here after filling this 1s2 and 2s2, I am entering into another orbital called 2p here. So 2p with 3 degenerate orbitals. 2p with 3 degenerate orbitals. The 3 degenerate orbitals. So what are degenerate orbitals? That orbitals which has equal energy. They are called as degenerate orbitals. So these 3 boxes together drawn called degenerate orbitals of 2p. They are namely here 2px, 2py, 2pz with equal energy. So here electron is filled. First one. Okay, boron, no problem. then where should I fill the second electron into the 2p with the carbon? So it has 6 electrons. 1s2, no problem. 2s2, no problem. And the 2px1, no problem. Then what about a second electron? Where should I fill? It is into the same or the next one or into the first one with anti-parallel spin, which is correct among the 3 red colored arrows. Can you decide according to your knowledge, what you gained or what you learned? So which among the 3 are correct? Can anybody decide here among the 3 which are going to be correct? So with our knowledge, we are unable to decide this one is correct or this one is correct or this one is correct. So we have 3 possibilities. Which among the 3 are correct? So I am unable to decide. I am unable to decide as I have knowledge. So with that knowledge, I am unable to decide. So one more principle is suggested here. There is a rule to fill the second electron into the degenerate orbitals. So if it is with one degenerate orbital, there is no problem. If it has more than one degenerate orbital, there is a problem raised here like this, as we look. So I am filling that electron into that 2px or 2py or 2pz with second electron, right? So 3 possibilities are there, right? Among the 3 possibilities, which is correct, that will be decided by one more principle called Hund's rule. So among these, right? So before going to fill that, I am giving you energy levels for filling the order into the orbitals. So that is given by here above. Is per above, 1s is filled first, the next 2s is filled first, 2p is filled first, 3s is filled first, then is like going on 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, then 4p6, 5s2, 4d10, 5p2, 6, sorry, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 4p6, 8s2. So can you count how many elements you are able to write here using these orbitals? How many electrons are filled into the last one, 8s? So including all these, 8s, 2. So shall we calculate here? 2, 2, 6, 2, 6. Then here 4s, 2, 10, 6, 2, 10, 6, 2, 14, 10, 6, 2, 14, 10, 6, and 2. So if you add all, finally you will get the count here, right? Shall we add all them? What we'll get? Just try to count with me. So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 2, 12 plus 6, 18. So here, up to here, I got total 18, right? Then 2 plus 10, 12, 12 plus 6, 18, 18 plus 2, 20, I got here 2, second, from the second. I got total 20. Then next, 10 plus 6, 16, 16 plus 2, 18, 18 plus 14, 32. Here I got sum. The next sum, 10, 16, 18, 32. Then 10, 6, 16 plus 2, 18. So total 8, 10, 10, 20. So to carry 3, 6, 9, 10, 12, 120 elements you are able to write using these energy levels. Have you got idea? How many elements you are able to write using these n plus L values? Only available orbitals SPDF. Are you following me? Is it clear? 120 electrons you are able to fill using these SPDF, right? If more than 120 elements are there, how many totally we have? 118. So 2 more you are able to fill. 2 more you are able to fill into 8s, right? So that is, then it is not the topic actually. Here using this, you are giving proper order to write the electronic configuration easily. by using the n plus L values only. So using n plus L values, we are introducing one simple method, right? According to n values. So n equal to 1 possible, right? N equal to 1 is possible. Sorry, what happened? I'll start sharing again. Just a second. Screen is visible. Just raise your hand. Give me your impression. Screen is visible. Yes. Okay. So now I'm sharing you that here simply based on that I'm introducing a simple method, right? So n equal to 1, n equal to 2, n equal to 3, 4, 5 like this. Then L values. So n equal to 1, L equal to only 0 possible is there, right? L equal to 2, sorry, n equal to 2, L equal to 0 possible and L equal to 1 possible. N equal to 3, L equal to 0 possible, L equal to 1 possible, L equal to 2 possible. Sorry, here number written wrong. It is 2. Then n equal to 4, L equal to 0, 1, 2, and 3 possible, not 4. Right? For n equal to 4. Then n equal to 5, we have possibilities 0, 1, 2, 3, 4. But I'm not required 4. L equal to 4 not required. Why? Can anybody answer me? I'm not required L equal to 4 here. Can anybody answer my question? N equal to 5 there. L equal to maximum possibility 4 there. But I won't go for L equal to 4 here. Why? Why don't we? In the world. Because these SPDF only enough for me to fill 120 electrons. If there is another element beyond 120, more than 120, 120 first element, that will go to G level, G orbital, right? So SPDF only enough. So L equal to 0, 1, 2, 3, not required 4 here. So that's why I'm not going for fourth one. If their requirement, we'll go for it, right? If there is requirement, we'll go for it. So up to now, we not required that. Clear? So here it is 2, here it is 3. Are you clear about this? Why I'm selected L equal to 1, 2, 3 only? Right. So now, for each, I'm taking a spheres, spherical shape, circles. So n equal to 1 to 8 possible with n equal to 1. L equal to 0. I have 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Then n equal to 2. It is possible 2p. So no 1p. No 1p. So I'm taking that circle n equal to 2 only. N equal to 1. 1p not possible. So I'm filling 2p here. So 3p, 4p, 5p, 6p, 7p. No 8p. Okay, then I'm going for n equal to 3, L equal to 2. So L equal to 2 means 0, 1, 2, SPD. So 3D possible. No 2D, no 1D. So 3D. Take it. Up to 6D. Then we are going for F. So 4F is there, 5F is there. So name them. 1S, 2S, 2P, 3PS, 4S, 5S, 6S, 7S, 8S. Next, 2P, 3P, 4P, 5P, 6P, 7P, 3D, 4D, 5D, 6D, 4F, 5. Then filling order. So according to the n plus L values only, I am following here. First 1S is filled, next 2S. So I am connecting with arrow. Next into 2P. After that 3S. Next 3P. Next 4S. Next 3D, 4P, 5S. I'm following the same order. Energy increasing order. Next 4D, 5P, 6S. Next 4F, 5D, 6P, 7S. Next 4F, 6D, 7P, 8S. Are you clear how I got this structure? How I got this structure? Are you following me clearly? Are there any confusion? Yes, no confusion. Right? So I got So now what I am doing here, just starting and endings are connecting. So after filling, 1s, where that electron going to the next level, 2s. So I am connecting 1s with the 2s, right? So here, so each one I'm connecting with the arrows like this. Yes, see, reverse order I'm going. Then that ends I'm connecting here. So after completing 1s, it is entering into the 2s. Next, after completing 2s, it is moving into 2p now. Next, after completing 3s, moving into 3p. After completing 4s, moving into 3d. After completing 5s, moving into 3d. Sorry, 4d. After completing 6s, entering into 4f. Next, after completing 7s, into 5f, then ending. So this is the order of filling electrons into the orbitals. The filling order of atomic orbitals proposed by Euler scientist. That's why it is named as Euler chart. Have you got idea how the Euler chart is designed? How the Euler chart is designed? So this is Euler chart story based on Apo principle. Based on Apo principle, right? So like this, we are following electronic configuration. In writing electronic configuration, this is the easy method which help you to write the electronic configuration. For example, if you want to write element 20, calcium, electronic configuration. So 20, here 2, 2, 6, 2, 6. Then next it is moving into here, 2. So I am following the same order. First 1s with 2 electrons, next 2s, 2 electrons, next 2p, 6, next 3s, 2, next it is going into 3p, 6, next it is 4s. So 20 completed up to here. So look at here, 2, 8, next 8, 4. So 2, 8, 8, and 2. So total you will get 20. So this is electronic configuration writing method. No need to by heart writing the electronic configuration. No need to by heart. No need to remember that Euler chart also. Already we understood how to make a chart, electronic filling into the orbitals. So based on that, I can write easily. If I understood n plus L values concept, and if that n plus L values are same, lowest n value. Are you clear about that? Are you clear about that? Yes. So no problem in writing. Only the problem with experimental values of electronic configuration found in case of chromium and copper. They are not according to your Euler chart, right? Below 30 elements, you have 2 elements that which will give you confusion in writing electronic configuration, right? In writing electronic configuration, they are here. 2 elements are found experimentally below 30, more than 2 there, total 180 elements, right? But here I'm suggesting you only 2. Remember, 24th element, that is chromium, and 29th element, that is here copper. So electronic configuration of chromium will be written as here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 according to your Euler chart. According to your Euler chart. But experimentally, we found here not 4s2, here it is as 4s1, here not, sorry, I'm written wrong. 4s2, 3d, 4, 24 electrons, right? So according to that Euler chart, you are writing electronic configuration like this, but there is a difference here, 4s1 and 3d5. So it is experimentally observed. The reason found for this different electronic configuration for the chromium is for the stability, right? Half filled or fully filled orbitals stable. So s orbital maximum capacity or maximum occupancy is 2. For d orbitals, maximum occupancy is 10, 2 each. So fully filled or half filled or stable, right? So 5 filled, half. So that's why it is showing you different electronic configuration. So chromium also, there is difference in the 4s and 5d. Sorry, 3d. 3d, 10. This you are writing for chromium and copper. So modify your electronic configuration. If you write with according to Euler chart, only chromium and copper differ in the electronic configuration. So before going that electronic configurations, right, we need to learn about one more principle, that is Hund's rule. Because I got contradiction in a above principle while writing carbon electronic configuration. 3 possibilities I am given, right? So how to solve that one? That is suggested by Hund's rule. So degenerate concept is there. The degenerate concept, that means degenerate orbitals filled with the electrons by the Hund's rules. So what is Hund's rule? So which are with the same energy, that orbitals are called here degenerate orbitals. The degenerate orbitals must be filled by one electron with the same spin, right? So before pairing, so before they filled degenerate orbital filled by 2 electrons, before that filling 2 electrons into the same degenerate orbitals, we must give each electron for each same energy level. So that is only Hund's rule here. So before filling that, it must be, before pairing, it must be with one electron into each degenerate orbital. For example, here electronic configuration of carbon I am taking as 1s2, 2s2, 2p2. In writing like this, there is no problem, right? So here, P maximum capacity is 6. So here, according to Pauli's exclusion principle, so 2 is the occupancy of each orbital. How many orbitals are required in P level? 3 required. So that found with the same energy level called degenerate orbitals here, right? So they are given as 2px, 2py, and 2pz, right? So that each will be filled by 2 electrons. So first you need to fill like this or like this. So that is only explained by Hund's principle. So degenerate orbitals 2px, 2py, 2pz are with same identical energy. So that's why they must be filled with one electron. So first electron, second electron. If there is third electron, it must go to 2pz. Then only fourth electron comes into 2px, not directly into second electron. Don't come into 2px directly. It goes to 2py. Third electron goes to 2pz. Fourth electron comes into the 2px. So that is only explained by here Hund's principle. So now look at that Hund's principle. According to Hund's principle, what we can write? First 4 electrons goes into the 1s, 2s. There is no problem. Then next 2 electrons must go to 2px and 2py. Each one first. Then only it comes into another. So 2pz next. After that 2px filled by second electron. So that we are following here. So unfilled electron present in the various orbitals of the same subshells should have parallel spins. That means upward or downward. What you are giving first, the next also same. So that we will see here. So electron should be paired with anti-parallel spins. So these are the Hund's rules main important things. So according to that, carbon electronic configuration will be written. So first 2 electrons filled into the 1s. There is no problem. So 1s2 completed. Next 2 electrons into the 2s orbital. So anti-parallel spins. Okay, I am following the anti-parallel spins only. 2s2 completed. Next, degenerate orbitals found in the 2p. So first electron is filled. Next electron not into the first degenerate orbital. That goes to second degenerate orbital called 2py. So this is the correct method. Not into the 2px. So 2px1, 2py1. There is no electron, 2pz, so 0 written. Are you clear about Hund's rule? Are you clear, everyone? Any confusion? Any confusion? So this is the order we are following. So by using this technique, you are able to write any orbital electronic configuration. Suppose 3D. 3D is there. How many degenerate orbitals found in 3D? 5D. They are what? 5. So number of degenerate orbitals are 5. So first each one will be filled with parallel spin. Then only pairing starts. So which numbered electron comes into again first degenerate orbital? That is 6th electron. So this logic you need to learn. Not second electron, it is 6th electron with anti-parallel spin. So this is Hund's rule advantage in writing electronic configuration. So this is about Hund's rule. Next, here methods of writing electronic configuration is there. Right? What methods are there, sir? Here that methods are 3 there. Writing that electronic configuration using the orbital method, using shell method, using box method. Right? So 3 methods there. So what the 3 methods? I will show you using only one element. Suppose let me take chlorine. So what is atomic number? It is 17. So what the electronic configuration I am following here? Orbital. What orbitals are? SPDF. So I am using them. So SPDF, 1s2, 2s2, 2p6, 3s2, 3p6, no, 3p5, 17. So 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 15, 15 plus 5, sorry, confusion. 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 5 is 17. So satisfied. So this is orbital method. Then shell method, chlorine, 17. So shell method is what? 1s2, 2s2, 2p6, 3s2, 3p5. So shell wise. So first level, N, main shell, K. Second level, N equal to 2, main shell, second level. So N equal to 3, main shell, third level. So N equal to 1, K shell. N equal to 2, L shell. N equal to 3, M shell. So this is shell method. This is shell method. Next box method is there. Same atom I am selecting here, chlorine with atomic number 17. Box method I am following here. 1s2, 2s2, 2p6, 3s2, 3p5. So box method. So 1s, only one degenerate orbital. 2s, one degenerate orbital. 2p, three degenerate orbitals. 3 degenerate orbitals. 3s, only one degenerate orbital. 3p, 3 degenerate orbitals. So this is box method. So fill the electrons with anti-parallel spin in each degenerate orbital. So this is called box method. So this is about writing methods of electronic configuration. So give me your quick reaction. Have you understood about this writing electronic configuration methods? Same atom used. So to avoid your confusion, I used the same atom in different methods. So these are the methods available in writing the electronic configurations. So with this topic, I completed chapter number 6, structure of atom, without leaving any topic. Everything is explained. Right? If there is anything missing concept, just bring into my notice. I'll discuss with you in the next class. So almost the time is 8. Okay. So this is about a second lesson. How do you feel? How do you feel about the second lesson? Give me your quick response. Don't leave this without giving your response. Unmute. Unmute. So first, who is Abhinay?
Sir,
How do you feel about my teaching 6th lesson?
Sir, I understood everything, sir.
So no confusion.
Yes, sir, no confusion.
Okay. Medhasri, now you can leave. Abhinay. Medhasri,
Yes, sir.
is it clear?
Yes, sir. It is clear.
So okay. Vikrant, what about you?
Sir, understood, sir. Thank you.
Thank you. So Surajita,
Sir,
what do you feel?
sir, understood.
Okay. Tejaswini,
Sir, understood very well, sir.
Richaran,
Understood clearly, sir. Very interesting.
thank you. So this is about the structure of atom. There is no class tomorrow. No class. So don't wait for my class tomorrow. Our class on Saturday. Right? I'll give you the time tomorrow evening. Okay. So thank you. Don't wait for class by tomorrow.